Hi class, sorry I'm not in class today. This should be relatively easy and quick though. We're going to actually do an introduction into 1.6, which is, the inequalities of absolute values, right? So we're going to solve inequalities of absolute values. You're going to finish all 6 problems. So finish all 6, okay, from that section. This should be pretty easy for you to do. I have a couple examples here. So here we're going to have example 1. This one's a relatively simple one. We're going with when is the absolute value of x minus 4 less than 6? So just think about when would be an absolute value less than 6. Well, you kind of do this in the exact same way as an equation, at least to start off. First, what you want to do is you want to isolate, right? Isolate the absolute value, which is already done. But then you want to rewrite. Okay, and your 2 possibilities in this case are the fact that the absolute value did nothing, done. Or maybe the absolute value turned a negative into a positive. The problem is, well, it's not really an issue, but basically we're then going to say, I didn't mean to put the absolute value back. We're going to say that x minus 4 is actually greater than negative 6. So notice how I flipped the sign. Hopefully this makes some sense that I have to flip the sign, because it doesn't really make any sense for the 2 statements to be true of x minus 4 is less than 6 and x minus 4 is also less than negative 6. That would be both in the same direction, right? And it doesn't really, it really wouldn't make any sense to do that. So that's why we're going to flip the sign. So when you get this absolute value, you not only rewrite it, but you also flip the sign. So you get x minus 4 is less than 6 and x minus 4 is greater than negative 6. Now, the question is this a or an and statement? Do both of these statements have to be true, or does one or the other? Well, if we are both less than 6 and greater than negative 6, notice what's happening. Basically on a number line, this isn't the solution, by the way, this is just kind of thinking about this overall. If I am less than 6, greater than negative 6, this certainly wouldn't be a or statement, because if it was or, I would be covering the entirety of the number line, right? Notice up here that all of the red line goes on forever in both the left and the right and overlaps in the middle. And so if this was an or statement, this would just be every number. That logically doesn't make any sense, because I could easily pick something that x could be where the difference between it and 4 is far greater than 6. So when you have an absolute value is less than, right here, what you actually end up having is a and statement. So less thans are and statements. Okay, now what we end up doing is we end up solving this pretty quickly. When we solve it, we just add 4, x is less than 10, and x is greater than negative 2. Now what I want to do is interval notation. And the interval notation starts at the low end. The low end is negative 2, and we want to include all numbers between negative 2 and 10. This is interval notation. Notice parentheses, basically parentheses means that the bounds are not included. Basically, if I plug in negative 2 into my equation, it should not work, which it's true. If I plug in negative 2, I get negative 6. Absolute value of negative 6 is 6, but 6 is not less than 6. 6 is equal to 6. And so that's why we want to not include the bounds being negative 2 and 10. So parentheses means you do not include them. When we do this next example here, so let me put this line here. First thing is, again, isolate. So if I isolate, I'm first going to divide by 3. When I divide by 3, I'm going to get 2x minus 1 is greater than or equal to 3, right? Just dividing both sides by 3. I then am going to do the exact same thing where I get 2x minus 1 is greater than or equal to 3, so change nothing. And then we have 2x minus 1 is less than or equal to negative 3. Now, again, I'm going to do a number line, not of the solution, but kind of what's happening right now. So 2x minus 1. If I have 3 and negative 3, we notice 3 would be over here, and negative 3 would be over here. So at the moment, where does 2x minus 1 reside? Well, 2x minus 1 is greater than negative 3, so that's from here on over, less than negative 3, so that's from here on over. So greater than 3, less than negative 3. This is clearly an OR statement, right? So these over here are part of your solution, or over here is part of your solution, right? So this is kind of what we're looking for. Now, 3s aren't actually the answer because we still need to solve this, but this gives you at least an idea of whether this is a or an and. This is a or statement. Oftentimes, I like to, a quick reminder, or this might help you, is just to think, okay, when you read this, you might read it as great or then. And then you say, oh, there's an or. I don't know if that helps you, but that's just kind of an easier one. And then less than is and. But anyway, so this is greater than, it's going to be an or statement. Let's continue to solve this though. So if I continue to solve this, I'm going to add 1. So 2x is greater than or equal to 4, and then x is greater than or equal to 2. Now we're going to still have our OR statement. This is now 2x when I add 1 is less than or equal to negative 2. X is less than or equal to negative 1. So it might be nice to put this on a number line as the actual solution. We notice negative 1 over here. We notice 2 over here. It's going to be a solid dot that way and a solid dot this way. So if I were to do this in interval notation, I'm actually going to say, well, all my solutions, the smallest my solution could be is actually negative infinity. Infinity is an idea, it's not an actual number, so we can't actually include it, so we use a parentheses. But then this thing goes all the way up to negative 1, and negative 1 is actually part of the solution. We want to include the bound there, right? So this bracket means that I want to include the bound. So 1 is part of the solution. Now, I can either write the word or, that's fine. I will allow you to write the word or there's another option. There's another symbol. If you did, so if you don't do or, you can also just do this symbol, which is called the union symbol, which is just a kind of an exaggerated U. So if you do the union symbol, that works, or the word or also works. We're then going to close this off with a bracket, negative 1. Oh, no, sorry. What am I doing? My bad. Bracket, where does the solution start back up? Starts back up at 2 and goes off to positive infinity. And again, we never include infinity, so parentheses are always on infinity. Always. Always parentheses around infinity plus or minus. So either positive or negative, you're always using the parentheses. Next. All right, so hopefully that works. Last example I want to do is this one. This one's probably the most complicated. This one's tough because since it's written the way it is, where it's a combination, this is actually an and statement in the middle here. So I'm actually going to immediately break it up into 2 separate statements. The first one being 2 is less than absolute value x minus 5. But I'm also going to say and, just written how it is, this is always and. Absolute value of x minus 5, close that, is less than 10. Now we notice, well, I'm actually going to rewrite this one so the absolute value comes first. Absolute value of x minus 5 is now greater than 2. This means that x minus 5 is greater than 2, or greater x minus 5 is in fact less than -2. Let's just continue to solve this one. When I do that, I'm going to get x is greater than 7, or when I add the 5 over, x is less than 3. All right, so those are possible. Now, this is all an and, so we'll just write and down here. This is a less than, so now we have to say, well, x minus 5 is less than 10, and, right, so it's less than, so and, x minus 5 is greater than -10. So we've got those two. Solving this, adding 5, x is less than 15, and x is greater than -5. Okay, let's see what all of this means. So I'm actually getting kind of two different statements here. So let's think about this one first. What might be nice actually is to draw a number line for this. So we know it's or, and that's pretty easy. It's going to start here at 3. It's going to go up to 7. I'm not going to include the 3, and I want to go down. I'm not going to include the 7, but I'm going to go up from there. Okay, so that's 1. Then I'm also going to do this. So it needs to also be and this over here. So let's actually do another number line. But this one is going to start all the way down at -5 and go up to -15. Now, since it's an and, it's actually going to start, oh, shoot, did I put -15? My bad, +15. It's going to start here and go down to -5 and everything in the middle. Okay, so let's now combine these two as an and, okay? So if I were to combine these two and do another solution with a number line, what I would get is I'm going to get, okay, starting at -5, then I'm going to have 3, then I'm going to have 7, then I'm going to have 15. I know part of my solution is here, where I'm going to, I don't know why I put those open. Sorry about that. I just noticed that I did that. Let's do open circle here, open circle there. There we go. Okay, so we're going to have open circle here, and everything in the middle. We're also going to likewise have open circle here going that way, and open circle here going that way. Now, between the red and the blue, remember, it is a and statement between the red and the blue in this graph. So if it's and, it needs to be covered in both red and blue. So the interval notation is here. It starts at -5, goes to 3, starts again at 7, goes to 15. These two are your solutions. To check, you can always plug in a number. So for example, I might want to just plug in 0. Does 0 work? Let's plug it into the original. So does 0 work? 2 is less than absolute value 0 minus 5, close absolute value less than 10. This is -5, but absolute value means it's 5. Is 5 greater than 2, but less than 10? Yes, it works. This is, in fact, part of my solution. Maybe I want to check this one. Let's plug in 10. If I plug in 10, I'm going to get 2 is less than 10 minus 5, absolute value is less than 10. 10 minus 5 is 5, absolute value of 5 is still 5, so 2 is less than 5, which is less than 10. Check. So again, this works, right? So these two actually do work. Maybe you want to check one that shouldn't work, which is like 5, right? 5 should not work. So if I plug in 5, I get 2 is less than absolute value 5 minus 5, close absolute value less than 10. 2 is less than 0, which is less than 10. Obviously not working. So here I just kind of threw in some numbers, checked the logic, everything's works out. Let's actually write the solution. So the solution is not including anything, right? None of the bounds should be included. It should go from -5 up to 3, but then there's a gap, right? And I'm not saying and in this case, I'm going to say or the next area that has the overlap of the blue and red is from 7 to 15. And here's our solution. So that's an interval notation. Hopefully that's helpful. I want you to finish that up now, and I will try to see you on, I don't know when I'm actually going to see you. Hopefully Monday. All right. Thanks, class.